Welcome to EDU World Space.
In this question, we have a firework launched from the ground level. Okay, so this is the situation. Okay, a firework launched from the ground level at an angle of 30 degrees, initial speed 25 meters per second, and then at the top it explodes into many fragments, two of them. Okay, two of them, one went up, the other one went down. Okay, and the angle is 53 degrees above and below the horizontal. Okay, in the fireworks frame. Okay, so we need to find the velocity of the two fragments and the angles with respect to the horizontal in the ground frame. Okay. Okay, so to solve this problem, we have projectile motion plus relative motion in this question. So first we need to write down what is the velocity of the firework at the top. Okay, the velocity of firework relative to the ground, okay, is equal to, I'm just going to write it as v f relative to g in the x direction. Okay, because at the top there's no vertical velocity. Okay, so the vfg for the x component is 25 cosine 30 degrees. Okay, and then I'm going to call the fragments A and B. Okay, for fragment A, okay, using the relative velocity equation, okay, before that, we first identify the components of the velocity of fragment A in the fireworks frame. Okay, so VAX in the fireworks frame, the x component is 20 cosine 53 degrees. Okay, and then the y component is equal to 20 sine 53 degrees. Okay, using relative velocity equation, okay, we have the velocity of A relative to ground for the x component is VA in the fireworks frame plus VF in the ground frame. Okay, so 20 cosine 53 degrees plus 25 cosine 30 degrees, and you get 33.7 meters per second. And then for the y component, and we have 20 sine 53 degrees plus 0, and we get 16.0 meters per second. Okay, so the angle with horizontal is the arctangent, okay, of the y component, divided by the x component. Okay, so 16.0 divided by 33.7. You take an arctangent, you get 25.4 degrees above the horizontal. Okay, then for fragment, okay, so this is one of the answers. Okay, then for fragment B, okay, the x component VB slash G, the x component is the same as VA slash G of the x component. So this is also equals to 33.7 meters per second. And then the y component is the negative of the y component of A, okay, in negative of the VA slash G of y component. And so this is negative 20 sine 53 degrees, which is negative 16.0 meters per second. And so the angle is equal to 25.4 degrees below the horizontal. Okay, because the calculation is still the same, you take the y component divided by the x component. Since there's a negative sign, so it will be below. Okay, and so this is the answer for fragment B. Okay, so the two answers are 25.4 degrees above and below the horizontal. And that's all for this question.